Hello, protocols, packets, and programs. This month we celebrate horror, especially its subgenres like hauntings, slashers, found footage, zombies, NPM packages, and pretty much anything that keeps you awake at night. Which means this week we chat with Kongyu Chan from Qualys about what keeps DevOps and SecOps up at night when securing Kubernetes, containers, and cloud-native applications. In the news segment, Text for Shell drops, Guac dips, Toner Def persists, OpenSSF scores, OWASP board votes, and more. Leave a light on and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly.
Passbolt is a free and open source password manager that allows your team to store, organize, and share passwords securely. Passbolt is privacy first and highly versatile. It can be installed on-prem behind your firewall, used in a secure cloud, or deployed as a cloud-native application. You can check out the source code on GitHub, extend it with the REST API, integrate it with the CLI or SDKs, and even contribute. Get started with Passbolt for free now. Check it out at securityweekly.com/Passbolt. The shift to remote and hybrid work over the past 2 years has accelerated application development on cloud infrastructure. However, securing these new assets has lagged behind. Qualys CloudView, the next generation cloud security posture management, delivers an end-to-end multi-cloud security and compliance solution encompassing the entire application lifecycle from build to runtime. CloudView enables enterprises to assess their cloud security and compliance posture, identify risks and gaps, auto-remediate issues, proactively enforce best practices, improve compliance and audits rapidly and efficiently. Identify your most vulnerable cloud assets by visiting securityweekly.com/Qualys. This is episode 217, recorded October 24th, 2022. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Good. Still morning. Still October. We finally have rain in Seattle, so something's changing, but one thing at a time.
One thing at a time. We'll wait, send some of that rain down here, or maybe some of that fog for a subtle horror movie reference. All you John Carpenter fans out there. And Adrian Barbeau, which I wish I could get that voice for a podcast. But since you can't get Adrian Barbeau here, you'll have to stick with me. And don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. Kongyu Chan is Director of Product Management at Qualys. Kong covers the enterprise platform, including data, infrastructure, security, and compliance. He has more than 10 years of product experience in enterprise software, covering data, multi-tenancy, and encryption. Hello, Kong. Thank you for joining us.
Thank you for having me here. Hi, Mike and John.
Yeah, we're happy to have you here, especially about, it's a nice theme of Halloween and scary stories about what keeps DevOps and SecOps up at night with securing all the things, or at least many of the containerized in cloud. And I wasn't sure how best to start into this, but maybe we could take advantage of Text for Shell as a vulnerability that's just come out, a 9.8 CVSS. But does that mean everybody has to scramble and fix it and dive in everything right now? Tell us, what does that mean to you when you hear Text for Shell 9.8 and we've got to fix things immediately?
Excellent question. The first thing we hear, it was based on the severity of 9.8. It looks critical, all right? But having said that, if you look at the details of these packages, Apache Common Text, it's not widely used by most applications. They're not an upstream usage of it. And secondly, not necessarily all users that uses these packages also use the library or the function that's impacted. Now, if you look at in terms of impact or potential exploitable of this vulnerability, it's pretty limited compared to Log4Shell and other potential vulnerabilities. So even though the CVE is high, 9.8, I wouldn't compare it with Log4Shell and other comparable CVEs. But having said that, because people are putting articles that compare Text4Shell with the previous Log4Shell, people may have the perception they are equivalent, and people may react to that. Having said that, I think all security vendors are providing solutions to detect the packages, but don't keep it you up at night because it's not that impactful as compared to Log4j.
Yeah, I'm sure we can find something else to keep us up at night. But you make the good points that you're adding that aspect of context, like the exploitability. Why, how worried should I be about this? Which leads to the other thing you said, which was prioritization. Do I need to fix this within the next 24 hours? Or maybe we could just have it part of a more regular fix. And that sounds great in theory, and it sounds really easy when I describe it that way. But on the AppSec side of things, it can be, I imagine it's pretty hard to keep up with all the other vulns that are coming out. So what are some ways you've seen AppSec teams or DevOps teams be more successful about tracking the risk of what's of whatever new vulns are announced within app software that might be present, might be running, might be worrying you?
Yeah, I think that's an excellent question, right? Firstly, most AppSec folks, as they build the application on their dev machine or in the CI system, they do want to make sure that they have tools that perform software composition analysis, and that would generate the software bill of material. And once you have software bill of material, you have a database of all the packages are used by your application, right? And definitely you want to know whether that application are deployed on production. Now, number one point is that if your application is using Apache Common Text, then the next question is to deep dive into your application, whether those applications are exactly using the function that are vulnerable, right? If their functions are not being used, then prioritization and fixing those changes would not make any impactful. Second thing, if you have those packages being used, Apache Common Text being used, and they are applicable, now the next question is that, does that mean your application are deployed on production, right? If the application is not deployed in production environment at all, therefore there's no exploitation because those applications are just not being deployed. Now, the challenge there for most AppSec folks and security folks is that most of these contexts are dispersed across multiple solutions. There's no single database or single platform that has information from AppSec on the dev side to the container runtime environment, and therefore that's where the difficulty about prioritization might be, taking some manual process of correlating those information.
Yeah, I think I want a lot of what we've been describing here is honestly just a generic, if you will, application security problem. What do you have? What's your inventory? What's the risk of it? Let's bring some of the Kubernetes containers aspect into this, perhaps, in the sense that there's got to be more to the security issues, security worries that keep folks up at night, rather than just like what vuln is present or what CVEs are these. So you mentioned too the difference between this is in staging, this is in prod. As you talk to different people, what do you encounter their concerns for, or the problems that they have for container security?
I think the challenge that most folks are facing right now is that most vulnerability management tools that are being used by different groups of people are not the same. And obviously security folks may have a separate tool, and the AppSec folks may have a different tool. And one of the concerns is that when they talk about prioritization, they may be using different tools, and they need to resolve the conflict about which are the vulnerabilities they fix immediately, right? And I think the fact is that if you just base prioritization based on CVE, internal criticality, it's not sufficient. Right, the business context, the user context are definitely important. For example, if those applications are running on production, providing revenue-generating results, therefore those applications may have higher priority than some other applications that are just performing some back office operation. Now, having said that, the challenge there is for most AppSec and the security folks to have some kind of common way of sharing information in terms of visibility, so that when they're doing prioritization, they're looking at the same information, looking at the same context, and look at real-time information. For example, what are the applications that are currently deployed on production? Because only those currently running applications are highly exploitable, right?
Yeah, and so I love the message there, but what I'm struggling with, my worry suddenly becomes, so is everybody just sharing their asset inventory, and they have a spreadsheet that says this is the important one, this is the unimportant one? How do we get out of that so the spirit of information sharing absolutely important, but the practice of it, how do we do something beyond just a spreadsheet that goes out of date after 2 days?
Yeah, I think that's an excellent question because I hear horror story where I hear people sharing spreadsheet after spreadsheet and they're trying to resolve the conflict by looking at spreadsheet. But as you may know, vulnerabilities information changes over time, right? Every day there might be a different set of reprioritization, right? So I think what people are heading towards to the trend right now is to have a common way of exchanging information. As you may know, even though people may be using different set of tools, different from different vendors, but they're moving towards using a common set of standard, which is SBOM, software biomaterial, and that allows people to have a common way of inter-exchanging information from one platform to another platform. And on top of that, they also allow, SBOM also allow software vendors to explicitly indicate that some vulnerabilities are excluded, because only the software vendors, when they build the application, they know exactly which functions are being used, which packages are being used, right? So just because the package is vulnerable doesn't mean that it uses the vulnerable API. And therefore, you could have assertion being provided by the software vendor saying that these vulnerabilities are impactful to this package. But having said that, because we are not using those API that are vulnerable, therefore, we would exclude this set of vulnerabilities. And most of the time, that means that the CVE that was like considered high and critical may be deprioritized, and that reduce the risk of false positive as well, which is helpful for everyone, right? When you have a common way of collaborating among vendors as well as security vendors where they can share information. And I think that's where we're heading towards too. And that makes everyone's life a bit easier.
Yeah, definitely. It has that context on the vuln itself, the package. What I'm curious about too is that if we, coming back to the idea of the containers, Kubernetes, or cloud environments, what about the business context? Because the SBOM, of course, isn't designed to capture business context because the vendors don't know that. So are there practices, are there design patterns that actually containers or Kubernetes enables better? Something like, something we can do through code that helps us with just tracking that business context aspect of things for the DevOps, for the SecOps side of
Excellent question. Most of the Kubernetes environment provide you the capability to perform adding metadata like labels and annotation. And the challenge for most organizations when they're running container environment, there's no mandatory requirement that you have to add specific labels, but the options are there. And with the options of labels, you could add information to images as well as Kubernetes containers environment. For example, each label that you create, you can add metadata like the business organization that owns this, right? And you can add who are the owners, right? So those are important information. Number one, if you add the business labels, you can clearly identify this application has potential business impact if it goes down and if it's not unavailable. Secondly, the second label that we need to add, which is the owner, right? Because if something goes wrong, we need to identify who owns this image. As you may know, in any large organization, we don't have the context of who owns specific assets because they are widely disputed across different organizations, or maybe the organization have many subsidiaries. So based on that, those image labels and metadata would be helpful. And on top of that, security folks would like to have labels or tags being added to the container environment so that they can clearly identify that when they're running containers, who actually is directly owning the containers, for example, the business unit, and from the containers, they can identify which image are vulnerable, and from the image that are vulnerable, they can identify who could actually fix it. And this is going back to the point. In container environment, the only way that you can fix the container vulnerabilities is to patch the image. Obviously, some folks may think about patching the running containers, but hopefully they don't think about that because it's not highly recommended. And because patching running containers is not persistent, right? Because container images are supposed to be immutable. So back to the point that given the context that you get those business labels and business tag, and as an organization, they need to sort of come back with a business score or criticality of the business score in terms of assets, right? For example, they can think in terms of revenue generation. For example, this application generates $5 million revenue per hour versus another application that generates $1 million revenue per hour. And based on those numbers, they could clearly articulate that these are the prioritization they should be focusing on.
I want to sort of pick your brain on that a little deeper, Kong. So you're just sort of we hopped from talking about SBOMs to I could go back further. Your comments around Excel spreadsheets were interesting, but we'll get back to that. But okay, so SBOMs, something fairly complex. A lot of folks are having an issue trying to even figure out how to generate them. It's this thing which has sort of become very popular this year, versus what you're just talking about with Kubernetes labels or container labels, which are quite easy to apply. And sort of where I'm sort of curious your thoughts on this is, at least last time I checked, there's no standard. The problem with the labels right now for me is there's no standard for labels. So if you walk into customer A, they might have figured out some sort of way that works for them internally. Then you go over to customer B, they either haven't done it or they've got some like maybe 2 fields. But it seems like the results of actually knowing who owns this application is a lot more important to me if I had a CISO hat on versus, what's in the SBOM. So what does it feel to you? Would you agree that it feels like we should have, as an industry, maybe focused on getting the basics in place first before working on SBOMs?
I agree with you. I mean, a lot of things that in general are based on conventions. For example, I'm just thinking of the same example. In most organizations where they name their computers, and for a while, people were just naming computers whatever names they want to put, right?
That's pet
which is not a great way, right? After a while, people start putting a standard, say, hey, got to prefix a host name with a region. Then they start generating names of the computer because they do not want to keep track of names. They want to make sure the names are unique. So the same problem with container labels and image labels. All those depends on the organization to come out with a standard. Obviously, you can ask for industry to come out with best practices and best standard. But having said that, as usual, just because you have a standard, it's an optional thing. Companies may choose a different standard for their own organization. The challenge that I think that most organizations, to impose that standard might be a challenge, right? Because they take some time to educate their teams. And usually within a company, I talk to people who are security folks, and they have to convince different application security folks or different application developers to use a consistent labeling mechanism. Because, for example, just like owner, right? We can say, do you use email or do you use the word owner as the keyword, right? Just based on these few keywords, right, there might be a big difference, right? Because if different organizations within a group, some folks use email, some folks use owner, that will drive some security folks crazy because they don't know which are the correct definition being used across the company.
Sure, but that's the result of not having that standard, which is sort of my point.
Yeah, which comes back that most organizations have the option of coming out with the standard. I think what we should do is that as an industry is come out with what are the key attributes that folks need in order to identify vulnerabilities and prioritize important information, right? For example, business context, owner, right? So some of those contexts has to be there. Even if I give you an owner without an email, it's going to be difficult if I use the owner as a person's name, because the person may change and an organization may be renamed. Right? It's constantly changing, right? So I would say that having a standard would be great, but the standard are a matter of providing the guidelines to most organizations to figure out where they are in terms of maturity and to evolve their adoption of Kubernetes and container and eventually have all those labels widely adopted across all their environment.
Yeah, I can hear some of our identity stack listeners out there saying, use the LDAP, not the email. But we'll set aside perhaps what this specific standard definition should be. But Kong, I like when you mentioned like what should we be tracking in the first place anyway? Because I agree with John. I think I would probably be more interested in, is there a human that I can reach out to say, please patch this, what's the patch status, rather than the business context. So, there is email owner, something like that. Are there other? We'll leave the naming convention to the industry to decide. But in addition to that, are there other of those best practices that you would recommend, or conversely, the horror story of labels, attributes that have gotten out of hand, that have either been too complex or just these are somebody an org tried to track them, but they ended up being just too unwieldy, not helpful.
I would say that if you have many organizations using different forms of labels, which I mentioned that some group may use as owner, some group may use emails, and that drives the security folks has to create a table or spreadsheet, again, getting a spreadsheet or documentation where they have to look up and say, hey, this label means who are the owner for this specific organization. And it goes back to the point that there's no innovation in all these labels, just that the company as a group need to be consistent and agree upon, right? I will always tell people some things are just not worth arguing for, right? Just be consistent. Choose a consistent standard practice across the company.
That seems fair. Yeah, be predictable is good. I want to. This is an awkward segue because I'm jumping now from labels and call it the process and management of the images. I did want to come back to the idea of of the containers themselves, practices there, because you mentioned, of course, immutability, a desirable. Hopefully, that is the property that is being enforced in practice rather than people, patching runtime. But there's also the concept of just reducing the attack surface in the first place, saying that we have all these dependencies that have their SBOMs, that have known vulnerabilities in them. But what if we reduce just how many packages are sitting out there on the golden image, for example, or the idea of a distroless package? What have you seen either the challenges or the successes in organizations trying to reduce a container image so that it's actually small and not huge, which are highly technical terms?
Yeah, excellent point. Part of it is that a lot of organizations, when they adopted containers platform, they are thinking in terms of lift and shift. And most organizations have existing virtual machines, and they literally lift and shift existing virtual machine into container. As you may know, a virtual machine may have the full-fledged operating system. And that's used to drive me crazy because whenever there's vulnerabilities, they say, hey, I have a list of vulnerabilities for these containers. And if I look at it, it's that most of the applications vulnerabilities are pertaining to the system, operating system in packages that are not being used by the application that's running in the containers. And which means that the footprint of this container is like as big as 8 gigabyte or even more than that, right? That's just ridiculously expensive to run these containers. Now, the key idea is that when people start thinking about containers, they're thinking of what can I do to remove the unnecessary package that are not necessarily used by my application. By removing unused packages, we definitely can reduce the potential image vulnerabilities as well as the effort to patch those issues, right? So that's why people talk about what you just mentioned, distroless operating system. And distroless means that they may have a basic system package, which is very basic, usually less than 100 megabyte, which is very light. And in fact, they have specific package for different language-based runtime. For example, Python runtime distroless, Go runtime distroless, Java runtime. And when you start using Java runtime distroless, which means that you are limited yourself to only the Java packages that your application needs. And therefore, you will reduce probably 80% of your unnecessary worry every day of trying to figure out which other package to be fixed. So I definitely suggest to my, whenever I talk to customers and users about patching vulnerabilities, I always ask them, are they using distroless? Because that will reduce a lot of their pain points as well.
Now, I'm going to guess, as maybe perhaps a rhetorical comment, that for as much as we've not standardized on the labels, I'm sure we haven't standardized on everyone use this distroless package. Everyone has an opinion and a favorite one. So with that said, I'm curious, when you do talk to the customers and they're trying to figure out either what's the distroless image, how we reduce the attack surface, do those discussions tend to be mostly the engineering side because they're the ones building the software? Are they getting influence or advice from security? How does reducing that attack surface? How do those conversations successfully flow within an organization?
When I talk to organizations, usually I talk to security folks, and the security folks will bring in the application or the developers into the conversation. And most of them may not have a common channel or common way of communicating, right? Because within an organization, you probably have many, many application developers across different organizations. And every application developers group may have a different choice of operating system, right? And that would create the complexity of managing those vulnerabilities across all these applications. And sometimes it was just a matter of education, right? Because some folks may not even know about using distroless operating system. They're just thinking about, hey, why don't I just use the full-fledged Debian packages or full-fledged Red Hat operating system. By the way, there are a lot of minimal base images, container images also coming up from Red Hat and other folks as well, right? Those minimal operating system, let's say Red Hat UBI, Universal Base Image, has probably less than 100 megabyte. I think it's probably like 50 or so, right? And SUSE and other well-known vendors also have similar universal base images. And the intention is that engineers or developers shouldn't be using the original ISO images that are like easily 650 megabyte, right? That will create a large image. And unnecessary images are going to create complexity because you're going to create a bigger footprint, which is going to take up more CPU and memory, and it's going to create a slower application.
Talking about performance and latency is always those are areas that can always appeal to engineers rather than talking about, you don't have to fix as many vulns, although I'm going to guess that's also an area of appeal. But as you're describing this, you mentioned earlier on about a distroless package or narrowing it down to this particular language. Here's our Java, Python, Go, etc. Mm-hmm. Does that turn into how do you manage this either from the engineering or the security side? Meaning, do you get a proliferation of images that this is front end team A image, this is front end team B image. These are the three back end images for different teams? Like, do they develop into team oriented images, tech stacks, or do people try to find that one image to rule them all with their the ever present Lord of the Rings reference for the ultimate container?
I think that's a bit challenging, right, for many organizations. But I think eventually most organizations would converge into not single base image, but they might converge to a few group of base images, because the complexity of managing multiple base images from different vendors is going to create a nightmare for security folks as well as the applications folks as well, right? And within the team itself, I wouldn't recommend any team who's building application to mix up all their base images, right? I mean, it's just like there's just way too many flavors of trying to figure out which are the vulnerabilities, because they have to go back to the source of those vulnerabilities, right? So if they're using Debian, Alpine, Ubuntu, and all kind of flavors, then they have to keep looking at upstream and looking at the vulnerability information. What is the latest information about this package that's provided by this vendor? But having said that, there's also different reasons from a business standpoint that people may choose to use different base images, because they might have a cost standpoint, or they may have existing contract they have purchased from those vendors in terms of base operating system.
So then now let's try to, I'm curious if we can bring the conversation of all that metadata and our images together. Is there an aspect of, one of the points you were making there was being consistency in the images. So does there become a way that we label the images beyond just who's responsible for fixing vulns that come in, what business unit it might belong to, and then it's fit for purpose sort of label? Here is the image for whether it's our language stack, our tech stack. Is there something, that aspect that you've seen, the labels that are starting to describe how or where these images should be handled, or am I going down a strange path there that isn't really useful?
I think those are useful. By default, there are some standard image labels that are being provided by the base image, and that will give people to identify this base image is coming from a particular source. Having said that, there are new technology and new trend that people are moving towards too. Because right now, whenever someone download a base images from Docker Hub or some of those container registry, they don't know whether those base images are coming from the specific vendor, right? For example, people could make a typo when they pull an image, and they could have easily pulled a fake injected image with some vulnerabilities, right? So as things move on, I think a lot of vendors are providing signed container image, and those images would allow a user to verify that I'm downloading an image from a specific vendor to make sure that, hey, this image is not being tampered. And as things goes on, people are also providing some more context about secure supply chain, and people are providing something called technology SLSA, which tells you whether those images are built according in a secure fashion. They have met some of the requirements to ensure that those images are securely built, and yet they also provide you a way to securely download the images from specific vendor. Having said that, it's not 100% guarantee, but at least you have some kind of assurance that people are doing what's right to make sure that those packages are secure, and the user itself can clearly check whether I'm downloading it correctly from the vendor. Because sometimes in some companies, what they're doing is that they are creating a proxy of those container images, because most companies do not want every engineer or every team to download packages from the cloud, because the image could be significantly large, and they are doing a proxy, right? They may have a container registry or some kind of artifactory that stores all images within their environment. And in order to pull the images from the cloud, they have to go through this proxy. And that proxy itself would also make sure that they are verifying that the images they are pulled from, let's just say Google, are verified and signed by Google, for example. And those are very important, because as things move on, we need to make sure that we are not only taking things from internet. It looks is free and easy to use it, but we also make sure that those images are secure by default.
Absolutely. And it sounds like, going that proxy route sounds like a smart centralization. So rather than have every individual developer remember to verify the GPG signature, just have it as one central part that gives you the thumbs up, thumbs down. But what you've also described is just, the provenance of that base image, what we're using. And then our developers go and put their, first party code. They put some of that, their own code on there. So how does that change the conversation in the sense that, well, we've checked the signature, we have the idea that we at least know the provenance, and this was built, this third-party resource that we're using was built in a particular way. How have you seen organizations then apply that to the own software they're building once that image starts to get customized and changed with the application layer code?
Are you talking about signing those packages for applications?
More like, the idea, yes. The idea of we can take it as a couple different ways. Either the provenance that we know that we deployed, the image that we deployed to production hasn't been mucked with by anyone that was outside of the developers who were committing the original code, or there's still the idea that these SBOMs from these third party resources, we can query them, they have known vulns, we can track them down. But we don't necessarily, how do we turn that into the own resources that we built, our own code that we built, and what we're deploying out to our Kubernetes clusters, for example?
Sounds good. So as you build any application into a container image, you do have a set of software build materials, which tells you which are the packages being part of this image. But having said that, when you deploy a container image into a running containers, things may change, right? Because there might be, for example, unknown malicious code that is being injected somewhere. And during runtime, you may see that there's unknown behavior, for example, and unknown behavior, which means that, for example, an application start downloading an application from the cloud and installing into your system. And that means that there's a drift from your original SBOM or your software packages. And that drift may indicate a malicious act, or maybe it could be a intention of the engineers to perform some weird action during runtime, right? I mean, I just want to call out, right? It doesn't mean everything that's unknown is malicious. but that's not a typical way of performing action to run application on your container image, because by default you want to make it single set responsibility. The container image does one thing well and has all the things that it needs. So container drift is something that requires some kind of runtime security to detect the changes. And what I meant changes that during runtime, you have different tools to observe the behavior of the containers to see whether those behaviors are considered unknown or malicious or digress from the original container image. And one example would be the software that's being installed on the original container image, and now you have another change in the production runtime where a program may accidentally or intentionally download a new RPM and install a new RPM to the system, and that means that there's a drift from the container image.
So avoid the drift, definitely. Then there is we talked about, you're talking about immutability again, alluding to that. Is there a way that is there something that you would recommend to organizations that are looking to mature their practices around containers? What's a short list? And I'm going to guess one of the things is to start off with something less than an 8 gigabyte image. And we've talked about distroless and some metadata, but what would be maybe, a few points that you'd say, here's how to start and then mature these practices?
I think the first thing is that make sure that you have all your images being labeled with those information, because number one, if you need to know who owns this image, that will be number one thing to make changes, right? You want to identify who owns it, which business unit. Those are very important. And those are very basic stuff which can be created in terms of best practices and convention that you can provide to your application developers. Given what you just mentioned as well, if you reduce the footprint of the container image, that will be a great way to reduce the potential image vulnerabilities, reduce the amount of effort to patch it, because you're not patching the whole operating system, because as you may know, a lot of vulnerabilities comes up every day and it may impact any of those operating systems. Those are low-hanging fruit from most security folks. I think one thing that people are not considering is misconfiguration, right? And misconfiguration is probably the most common vulnerability attacks, which means that people misconfigure the Kubernetes cluster, where anybody could access the cluster itself. There's potential attacks that anybody could just scan the internet and look at any cluster that's open. For example, the Kube API server is open to the internet and people could easily access it, and there's a role that is being read-only and people could look at all your clusters. So those are probably the basic low-hanging fruit that people should be looking at. Misconfiguration and making sure that your images are secure by default.
Excellent advice. And once again, it's probably going to keep people well occupied to do the basics before they get into anything else. Thank you for that list. Kong, I want to say thank you for joining us. Is there any other final words that you want to share with our listeners?
Well, I would say that for container images and security, always think about securing your images right from the start, and think of automation. Because as you have automation, you can continuously secure your images, scan it, prioritize it, and also think in terms of how would you automatically patch your images all the time.
Awesome. Yes, I'm going to add the metadata here is, once again, thank you, Kong. That's the label I'll throw here. Thanks for joining us.
Thank you, Mike. Thank you, John.
I want to say thanks, John, and thanks to all of our listeners. To learn more about Qualys, visit securityweekly.com/Qualys. And with that, we'll take a quick break and return with news of the week.